Welcome to the technical walkthrough for Shardeum's audit competition. This is Shardeum's third audit competition focusing on Web3 components of their project. This competition covers 4 key areas: Shardeum's core protocol, Shardeum validator nodes, networking, libraries, and crypto utils. We're thrilled to have Mehdi and Tim from Shardeum's team here with us today. Both of them will walk us through the core components of their code base, provide an in-depth look at the code, and share key insights to enhance our understanding. From the Immunefi side, I'm Daniel, and I'll be co-hosting the session alongside the Shardeum team. Without further ado, I'll pass it over to Mehdi to dive into the technical details.
Okay, thanks, Daniel. And thanks, Tim, for joining. So let me share a screen real quick. So just as with our previous 2 rounds of boosts, we've split our code base into 2 different audits. One is the core and one is auxiliaries. For this presentation, we're just going to talk about the core audit competition. So this audit has, I think, 70,000 lines of code total in that ballpark. And as with the previous ones, we've provided a proof of concept scaffolding to help white hats get their proof of concepts in motion off the ground, and then a way to make sure that when you submit your proof of concept, the Shardeum team can run it and verify that it does what you say it does. So a high-level overview of how the Shardeum network works is it's designed for anyone to be able to run a node, start at their node, set their stake. It's a staked network. It's kind of proof of stake with a few quirks. We call it proof of quorum. So that you boot up your node, you join the standby list, and then completely randomly, the network chooses nodes from the standby list to pull into the active network, and then your standby node will become a validator node. Once it's in the network, it's validating transactions, doing consensus and signing. After a while, deterministically, it'll be rotated out of the network. This node rotation is a key part of the security posture, the security strategy of Shardeum. So the nodes that are in the network do the validating, and they get the transactions, do the validating, do consenting, and then once all of that's done, all of that network is sent to what we call archiver nodes. Now, when we launch, archiver nodes are going to be run by Shardeum. We hope sometime after mainnet launch that the archiver nodes will be open and available to run by anybody, just like the validator nodes. But that's something we'll have to grow into as we understand the use and the needs of the network a little better. So let's see, standby nodes rotation. Oh yeah, something specific for the bug bounty here is that not everyone will be able. We have a network that we've provided for the white hats. It's up and running by Shardeum Foundation. Not everyone will be able to create a node on that network, but anyone can send transactions to it and test their proof of concept. If you would like to run a node, then you'll have to DM me in Discord, DM the Shardeum team, or you could do it in public, and send us your wallet address so we can send you some test SHM to stake. And then also send us the public key of your node so that we can add it to the network whitelist. We plan to launch with this sort of network whitelist, even though the goal is for anyone to be able to run a node. At launch, we'll have a whitelist, and this whitelist is fair game for attackers. So if you find a way to bypass the whitelist and get your node into the network without pre-approval, submit that, and that might be paid out. So there's one more part of this document that I wanted to go over a little bit. So here is another diagram. So the validators at the top, this is the network architecture at the top with all the active validators. So they do their consenting, and then once they're done consenting, they send their data to the archivers, and the archivers hold a whole history of the network. So the validators only hold the past handful of cycles. I don't remember the exact number. Everything else is on the archivers. And the idea behind this is that the archiver nodes will be bigger, beefier machines that hold the whole history of the network and are ideally we're targeting this to not be run just by any random user, but to be more run by institutions who want to do their analytics or whatever, that they have more resources to manage a big server that needs to be available and have a lot of storage. And then this archiver makes the network data available to third parties. That includes the Shardeum Explorer or any Explorer run by any third party, available to exchanges who might need the history of the network, things like that. And these third parties and these entities get the data from the archiver through what we call the relayer, which is a combination of the distributor right here and the collector down here. And this is how the different elements talk to each other. Let's see. I believe that is a major overview of the Shardeum network, and especially, let's see, for the core audit competition, the archiver is out of scope. That'll be in the ancillaries, which we'll do a video on pretty soon. For the core, we're just focusing on the validators, and there's two parts to the validator. There's the validator server itself, and then there's the P2P code, which we are calling Shardeum Core. And then the supporting libraries around that, there's a Rust networking library, and then also a crypto utils library that we use for signing and verifying signatures and whatnot. So for a little more deeper dive, I'm going to pass it over to Tim, and he'll talk about transaction flows and a bit more technical stuff. So Tim, you want to take it from here?
Yep. So let me share my screen. Do you see my screen? Do you see my screen?
Yeah, I can see it.
Yes.
Okay, cool. So what I want to start with the kind of high overview of the repositories. Let's say start with the Shardeum Core protocol, right? The main parts here is P2P folder, which contains like contains the low level, I would say, cycle chain related logic. So idea is our protocol has like two levels. We have level related to the network architecture, and we have level related to transactions. So this P2P folder, it describes the level related to cycle chain structure, which kind of controls how node join the network, how node leave the network, how like monitoring is happening, like, and all of that stuff. So the stuff related to the transaction is mostly in a state manager. I would say the three main files here are transaction consensus, transaction queue, and transaction repair. So transaction queue contains mostly the logic related how transactions are processed. It's a pretty big file. I will describe it in kind of in details just a little bit later. Transaction consensus contains logic related to one of the phase in this transaction processing flow related to the consenting, how consensus is reached in a validator network. And transaction repair is like corner cases when transaction cannot be processed, how it will be processed in case of if we have some issues with some validators, whatever. So the next report is a Shardeum. The Shardeum is like everything related to how accounts are stored. It's all will be inside the Shardeum report. So here, I would say there is no something which is more important, some folders which are more important. So they're kind of evenly important. So yeah, so let's go to the next one. The next one is archiver report. For archiver, we have two main parts. The main part, one part is related to the logic when archivers are talked between each other.
Hey Tim, let's so archivers in the ancillaries.
Okay.
So we'll just focus on the core.
Okay, cool. Okay, so let's go to the transaction flow. right? So I did some kind of high-level ChatGPT kind of cloud AI generated code-based description based on a code we have. So transaction flow we have like a multiple states. Let's discuss the success path, I would say. So when transaction is injected, it stays in a aging phase. The purpose of this aging phase is kind of synchronize nodes between each other. So I think it's like 7 seconds or something like this. So yeah, the idea is like initial buffer state when you receive the transaction, all the transaction to accumulate before processing begin, give time for network synchronization. So there are some kind of timers which defined in the variables which needs to pass, so transaction can go to the processing phase. So the next state is a processing. The idea of the kind of processing state is when the nodes start sharing the data it owns to the other nodes in the network, in case it holds some data, it stores some data. Let's say if we have two accounts, account A and account B, and our node is from the consensus group of account B, it needs to kind of share the account data about account B to the other nodes in the network, so the transaction can be executed in a kind of distributed mode. So after the processing mode, there is a processing state. There is a awaiting data state. The idea of the awaiting data is when the node sends the data it holds, it starts waiting for the data from another nodes, which are sending when these other nodes in the processing state. So it's kind of the node needs to accumulate all the data needed for the transaction to be executed locally on the node itself. So primary state of collecting and validating account data required for the transaction processing, ensuring data consistency across nodes before proceeding with the transaction execution. Yeah, there are some entry conditions, how the data can be received and sent from the other nodes. I would like to make an accent here, like to pay attention, kind of to review the function which actually defines how the target nodes to which the data is sent is selected, and how this verification is done on the receiver side, that the sender is the valid sender for the account data. Why it is important? Because if malicious node can bypass this verification check, the account data which will be used for the transaction executed will be invalid. And you, let's say, malicious node can say that this account balance was not like 100 SHM, but it was like 100 billion SHM. We had that issues before. This was fixed, but I think this is worth to check again, right? So when the data was collected in a waiting data state, the node is switched to the consensus state. The purpose of the consensus state is to kind of to verify that the result of the local transaction execution is the same between other nodes in a network, right? So the idea is after the node execute transaction locally, it gets the result and start exchanging this result with the other nodes to understand that the result is the same. So the network can come to some kind of consensus what is the result of the transaction. So after this consensus was reached, nodes start exchanging the final data result. And the nodes will go to committing stage. During this stage, the nodes exchange the accounts data, which will be the result of the transaction execution, and the node will update this local storage with this new account data. The other states are kind of corner cases when we have certain kind of issues in transaction flow. I would say that we need to, the white hats, it's better to go deeper to these states like await repair and canceled, because usually the more attention is done on a success path. So if you will go to this corner cases, I would say you can probably will find some kind of bugs there. Yeah. So other parts which I want white hats to pay attention to is we added new silver or Genesis accounts logic. The idea of this logic is that only a certain list of accounts from which stake is coming to the node will be eligible for the participating in a validators network. Yes. So the logic is done on a stake phase. So when the node is staking before joining the network, the network is verifying that the sender account for the stake is in the eligible list. So I think this logic needs to be verified because it's a new logic. It's a pretty simple one. It's based on a file, I think. Yeah, verify stake.ts. It's a new logic which is called from apply function, which apply the staking transaction. So it verifies that the sender is in the list. This ticket. Just a second. Yeah. Anyway, so just go to the verify stake file, and you will see the new logic related to the Genesis accounts. Other part which I want to pay attention is related to service queue. Yes, service queue.ts in a core report. This logic is related to network transactions. Network transactions are specific, I would say, service transactions related to how the rewards are initiated, how rewards are claimed, how the config in the network is updated to make this network transactions more reliable to the node restarts and some kind of corner cases. There was a specific feature developed called service queue, which is kind of persistent, kind of idea to persist the network transactions between the restarts. And this logic is new, and I think it's worth to pay attention to this feature because it can have like probably can have a bugs too. I think that's it from my side.
Yeah, I think we're good. Daniel, do you have some questions?
Yes, guys. So thank you very much, Mehdi and Tim, for this insightful, detailed walkthrough. So before we wrap up, let's highlight a few key takeaways to help security researchers identify vulnerabilities more effectively. And the first question I have is, what are the most important bugs you have received in previous audits that you haven't expected to see? And how did that challenge the security assumptions of threat modeling in your system?
Yeah, sure. So the one I always talk about when people ask this is the issues we were having with the multi-sig and signatures in general. So this project, it started off as, you know, when the project started, it was very ad hoc. You know, we were trying to get new developers, you know, people new to the programming field, invite them in, train them up, and as opportunity to learn. And it was kind of like a research project. So we didn't have a lot of set standards that a mature project would have. Now we've grown a lot more mature since then. But as we were going, we've had reports of multi-sig specifically being a little gummed up. For example, if you needed 3 signatures out of 5, there was one report a little bit ago that you could actually have the same node signed 3 times, and that would count as 3 different signatures. That is a critical bug. We are so happy that someone found it, and is delightful. Anyway, Tim, do you have an answer? Do you have anything you'd like to add?
Yeah, the most crazy one for me was like when the guys can craft the signatures from the nodes for any P2P message. Remember when the payload was not restricted, you can send to some service which can generate signature for the node, so you can actually ask the nodes to sign any payload you want. Yes, so
I do remember that. Yep,
that was super critical.
So we as a team had a lot of maturing to do around signatures.
Yes, and I think another one was related to the validator archiver communication. Like we had like a lot of issues there, so we're fixing this. Like it's very, very important stuff too.
Nice. And related to these first questions and the answer you gave, what are the most important areas you feel people should focus on looking for bugs or critical areas?
Transaction consensus. We've had a lot of bug reports that are focused around processing JSON, processing inputs, unvalidated requests, things like that. We would love for people to dig in and get into the transaction consensus. I have a hard time imagining a bug in consensus that would not be a critical bug, and we feel like it hasn't been. It's fertile ground for bug hunters. Tim?
I would say not only the EVM transactions, but also there are second type of transaction, which is like a service transactions, like a network transactions. They are super critical for the network to be stable. Let's say one of the transaction can update the network config, right, which will be distributed across all the nodes and will change the behavior of the validators. That is super critical thing. So I would say kind of paying it, like kind of reviewing the service transaction flow, especially service queue, can be critical for us. Like it's very important.
Yeah, and just to be clear, the EVM is out of scope. I think you meant like coin transactions.
Yeah, I mean coin transactions. Yes.
Yeah.
Fantastic. And any tips or suggestion on what to look for in your code base, like which area specifically you would like SRs to just magnify?
It's more like a core repo, I would say. And as I said before, it's like a service queue TS for the network service related transactions, right? And verify, just a second, verify. In a server report, there is a verify staked.ts, which is related to Genesis node functionality, which is also super critical for us because we want to run our first version kind of based on kind of list of allowed node owners. We don't want any other unknown node to be running in a validators network. So this is also critical. These two parts, they are new. These parts are new. They didn't have probably too much attention. I mean, eyes on it. So
that's a good point. Yeah, that is new code. That's the whitelist I was talking about before. So the if you want to get on the whitelist to run a node in the test network, that would be you would be running a Genesis node. The code around that is fresh.
Okay. Like, and then what do you consider to be the best resources to learn more about this specific area you just mentioned, but in general, the code base?
So I would start for get a big overview in just the Shardeum documentation. I know that's a canned, uninteresting answer, but it will really help you understand the differences between Shardeum and Ethereum and other EVM compatible networks. And I say that because we are trying to do something novel and unique here with the Shardeum network. Like other networks have, I know Ethereum has discussed sharding. I think that's in their request for comment stage. They're not any closer to pushing it out. Like I believe that we're really close to unveiling this new technology. So go read the documents, and then beyond that, once you get a high level idea of how the sharding works and what we're trying to do, go dig into those previous paid out bug reports on Immunefi. They're linked in the audit competition page, I believe. Yeah, we've had 2 rounds of audits before. Go dig into those. That'd be a great way to understand what's going on.
Okay, first the documentation, then be knowledgeable through the reports that have been submitted in the previous audits, right?
Mm-hmm.
And then what are the different access control roles within the protocol?
So, okay, there's not many different levels. One in the users is there's your typical everyday like transacting user wallet on the network that should have like the basic permissions and whatnot. Then there's also debug endpoints on the network that will be disabled except for high-level developer keys at the beginning. So you'll be able to see these debug endpoints. I believe we have a question coming up about them pretty soon. But if you're able to access those debug endpoints without having a developer key, that is an access control. That'll be a bug that gets paid out. And then beyond that, it's the Genesis node thing, and also the Genesis node and archivers. But we'll talk more about archivers and the ancillaries. But for the Genesis nodes, like if you're able to join the network without being on the whitelist, that is also a trust boundary you're violating. That'll be paid out.
I see. Amazing. And what are the areas of interest for the whiteheads, which will be challenging for auditing, and what area of the code do you think has the potential for most bugs due to the complexity involved in the implementation? I guess it's like around the same topic.
Tim, what do you think?
There are 2 parts: new code and the complex code. New code, we mentioned before, is related to the Genesis node. It's in a server repo verify stake. Service queue in a core repo related to the networking transactions. And the complex one, I would say, we didn't see any bugs related to repair phase, right? But repair phase is very complex in terms of time synchronization. I'm like 99% sure that there will be some critical security bugs there in the repair phase. Yes.
Okay. And the last question, not sure if Mehdi, Tim, this is related to ancillaries that I see here in red. I would love to know how the bag middleware works. Can you provide a general idea, please?
Yeah, sure. Go ahead, Tim. Yeah.
Yeah. So idea, we have the specific API endpoints which are used by developers. These API endpoints are covered using the debug middleware, and this debug middleware has 2 versions. One version is when the request should be signed by single developer key, and each API endpoint is set what level of the what security level of the developer can be used to access this API endpoint. We have 3 levels, which is low, medium, and high. By default, I think it's a high level. So if API endpoint is not set to level, the default level will be high. The idea is each request to this API endpoints should be signed by the developer key with a certain level, and signature is provided as a part of the request, right? So if signature will not be provided as a part of the request, by the way, it's a general HTTP API endpoints. If signature will not be provided, it will be the request will be rejected. Yeah. So the whole logic is done in a handle debug alpha function. Logic is pretty simple. We had, by the way, we had a few bugs on a previous bug bounties related to some absence of the required parameters, which resulted in a request replay attacks. It was fixed. And the second way of authentication for the service API endpoints is using the multi-sig way. So in this case, not only a single developer should sign the request, but several developers should sign the request to API endpoints which are covered by this authentication mechanism. And it's done in the same way as a single debug auth, but with the just additional requirement that we need like several keys presented in a HTTP request.
Okay. Thank you so much. And yeah, that was the last question. There was a lot of information. It was really valuable for everyone who would like to hand on your code base. If you have any follow-up questions, don't hesitate to reach out to the Shardeum team via their dedicated Discord channel. As a reminder, the Shardeum Core III audit competition is live on Immunefi with 250,000 reward pool, and it is available until February 12th. For more details, you can visit the page on Shardeum audit competition on Immunefi website. And another reminder is that to join the testnet that Shardeum is running, please ping the project team here in Discord channel to get your EVM address whitelisted. Thank you once again, and happy hunting.
Thank you.
Thanks.
Thank you.